All right. Hello, class. This is chapter 13.12 for Algebra 1, Finding Distance. So, did you know that you can use the Pythagorean theorem to find the distance between any 2 points? Well, yes, you can. So let me show you how that goes. First, let's say you had a normal XY coordinate plane. Of course, you have your y's up here, your negative y's down here, your negative x's, your negative x's over here, and your x's over there. Okay? And let's say that there were 2 points on the plane. And let's say that's where you and your friend were. Okay? So the first point is at 1, 6 up here. That's where you are. And we'll draw you. There you go. And the next point, which is where your friend is at 4, 2. It's probably a little higher than that. Right here at 4, 2. And there is your friend. So if we drew a line between the two of you, this would be the hypotenuse of a triangle. Specifically, as we know, hypotenuses or hypotenuse go to right triangles. So perhaps you can already see where a right triangle could form. If you drew it straight down here and a line straight across here, we see that we have the lengths of legs for a right triangle. Now let me take some time to fill in some of the points here. We said this was x equals 4. So let's say that's 3, that's 2, that's good for a place for 1, and of course 0. We set up here as 1, 6, so let's say that is 6 for y. We can draw some more space. 5, 4, 3, oops, 2 is way down here, 2, and 1. All right, clearly this is not to scale, but this is the idea. In fact, let me draw a little bit more to scale so people do not freak out. I'm going to say a 3 is like right here, a 4 is right here, and a 5 is right. Okay, that's good enough. All right, so now, how do I determine what the lengths of my sides are? Well, I just simply count. So if I know that this point right here is 1, 2, because I've drawn it to scale, which I haven't done here, but let's assume. This is 1, 2. Well, isn't the distance all the x values in between, right? So what's the distance between 1 and 4 on the x coordinate? All I have to do is say, all right, it's 1, 2, 3. You could also have done 4 minus 1 would give you 3. So this leg right here is 3 units. I'm going to draw it in blue, and it's 3 units. It could be 3 feet, 3 inches. We don't know. Right now, we don't care. We just know that it's 3 units. What about up and down? The up and down I will draw in red. We're going from 6, y is 6 to y is 2. Well, that's 6 minus 2, which is 4. And sure enough, 1, 2, 3, 4 until we reach. That's a distance of 4. All right, so now I know that one of my legs is 3 units, and I know the other one is 4 units. And what I'm trying to figure out, since this is a 90-degree triangle, is what my hypotenuse, which is the distance, which is going to be the distance between you and your friend, okay? So using the Pythagorean theorem, I can substitute a squared plus b squared equals c squared. My a squared will be my short side, which is 3 units, so it's 3 units squared, plus b squared, which is my long side, and then I'm looking for my c squared. Oh, I need to move this so that you can see. So here we have it, 3 squared plus 4 squared equals c squared. I do some basic math, 3 times 3 and 4 times 4. to which I will get 3 times 3 is 9. 9 plus 16, this seems familiar, equals 25. 9 plus 16 is 25, and I see we're going to have a special triangle here. I'm going to rewrite this point so I have some space. 4 over 2. 9 plus 16 is 25. 25 equals c squared. I use what I know to get rid of a square root by using the radical symbol, which removes the square. And what I do to one side, I must also do to the other. So I say, what is the radical or the square root of 25? And we all know it's 5 equals c. And sure enough, my hypotenuse is 5 units, which means the distance between you and your friend is 5 units, whatever that is. In this form, we call that the distance formula. We can use the Pythagorean theorem to find out the distance between 2 points. Let's try it one more. Let's say I had, let's use a negative. That would be good. I have an xy plane, and my points are -4, -3, and 1, -6. So let's draw that now. I'll draw this one in blue. So 1, -1, -2, -3, -4, -5. And we'll go down 1, -1, -2, -3, -4, -5, -6. My first point is -4, -3, so I go to the left 4 and down 3. That puts me right here. 4, -4, -3. Already I can tell, well, I don't know that yet, so we'll wait on that actually. And my next point is 1, -6. So I need a +1. And I need to go all the way down to -6. And that puts me at this point right here. And I'm trying to figure out what the distance is. That's +1, sorry. 1, -6. And I'm trying to figure out what the distance is between these 2 points. Okay? Oh, let me move that over there. So the first point is -4, -3, and the second point is 1, -6. Well, I need to find some place where I can draw a right triangle. And I think I see one right there. If I draw a line continuing down from this point, and I draw a line continuing over from this point, I can see that I can create a right triangle there. All right, now I have to find out what this point is, and it looks like it's the point -4 on the x and -6 on the y. All right, now I have to say to myself, okay, if I'm going to use the Pythagorean theorem, I'm going to need the lengths of each side. So let's figure out what is the length of this side here, this first one. Well, I'm measuring vertically, so I need to know what the y values are. I've got a -3 and a -6. If I want the distance between two numbers, I go where I'm ending up minus where I started. So this can also be considered y2 minus y1. And that is -6. A negative minus a negative is a positive. So -6 plus 3 is -3. But we remember, distance is always a positive number because there's no way you can do a negative distance. Sure, you might say turn the other way. That's not really negative distance. You still have to travel. So because you have to still travel, we call it positive. You still have to do something active. So that's 3 units right there. I can draw it in blue so we can differentiate it. So this leg is 3 units. And let's see how many, what the distance is for this leg. Well, it's going left to right, so we're talking about the x values. So in the same way, we start with this where we ended up, which is x2, minus where we started, which is x1. x2 we'll call this -6 right here. No, sorry, not the -6, that's a y value. The 1, which would be our x2. So I write 1 here, minus our x1 value, which would we call the -4. That's where we started. So again, it's minus a negative number. So we have 1 minus -4 is a negative minus a negative, so that's a positive. 1 plus 4 is 5 units. And sure enough, to get from -4 to 1, you have to add 5. And sure enough, to get from -3 to -6, you have to go 3 units, okay? So now I have my A value. I've got my B value, which is 5 units. And now I'm just waiting on my C value. And my C value will be my hypotenuse, which will also be the distance between the 2 points. So I know the Pythagorean theorem says a squared plus b squared is equal to c squared. I know my a value is 3 units because we did the math to figure that out. So it's going to be 3 squared to satisfy the equation, plus b squared, which is 5 units at this time, equals c squared. We don't know what c squared is yet, so we're going to take some time to figure it out. 3 squared is 9. 3 times 3, I'll write it all out, is 9. 5 squared is 5 times 5, which is 25. And then we've got c squared, which we're still trying to figure out. I'll move my face down up here. Okay, 9 plus 25 is 34, if I'm not mistaken. Correctamundo. 34 equals c squared. I need to get rid of the square on one side, so I take a radical to it. That eliminates it. What I do to one side, I must also do to the other. And so I now have rad 34. Now some of you are saying, well, what is rad 34? Rad 34 is, I have no idea, but if I had a calculator, I could do it. In fact, I should do it just to prove that I'm typing into my calculator the radical of 34. I have a commercial on. That's great. All right, free apps, you know. 34, square root of 34 is 5.83. So you can leave the problem as, oh, that's great. It erased everything. No, it didn't. There it goes. Come back to me. That's strange. 1 second, sorry. There it goes. All right, so you can leave the answer rad 34 equals C, which is a perfectly legitimate answer. It's a more precise answer. Or you could reduce it to 5.83, I think it was, or something like that. Either way, you have found your distance between 2 points using the Pythagorean theorem. All right, hopefully that is helpful. And for those of you who are saying that's not the distance formula, well, let's take a look. The distance formula is distance is equal to the square root, doesn't that look familiar, of whatever your x squared value, well, not x squared, your second x value is, minus the position of your first x. And then you're going to square it. And then the rest of it is subtraction. Or no, it's addition, excuse me. Plus, what to do? the position of your second y minus the position of your first y. That gives you the distance between 2 points. And you're also going to square that. And that's basically what we just did. We did the distance formula, but we broke it down into what is a squared plus b squared, which would give us c squared. But remember, once we finally found our answer, we had to reduce the c squared or simplify it using the radical symbol, which left us with what we have. So basically, we did do the distance formula, just transposed and rewritten. All right, I hope that helped. We will see you in the next video.